morning, students. Today we are going to discuss about introduction to UML. UML abbreviates Unified Modeling Language. UML is a standard language for specifying, visualizing, constructing, and documenting the artifacts of software system. UML was created by the Object Management Group. In short, it is called as OMG. And UML 1.0 specification draft was proposed to the OMG in January 1997. OMG Object Modeling Group is continuously making efforts to create a truly industry standard unified modeling language. UML stands for, as I said, Unified Modeling Language. UML is different from the other common programming languages such as C++, Java, COBOL, etc. UML is a pictorial language used to make software blueprints. UML can be described as a general purpose visual modeling language to visualize, specify, construct, and document software system. Although UML is generally used to model software systems, it is not limited within this boundary. It is also used to model non-software systems as well. For example, the process flow in a manufacturing unit, etc. UML is not a programming language, but tools can be used to generate code in various languages using UML diagrams. UML has a direct relationship with object-oriented analysis and design. After some standardization, UML has become an OMG standard. So these are the points in introduction of UML. Goals of UML. Yes, a picture is worth 1,000 words. 1,000 words may not be equal to a single picture. This idiom absolutely fits describing what is UML. Object-oriented concepts were introduced much earlier than UML. At that point of time, there were no standard methodologies to organize and consolidate the object-oriented development. It was then that UML came into picture. There are a number of goals for developing UML, but the most important is to define some general purpose modeling language which all modelers can use to it, also needs to be ఒక నిమి- ఒక నిమిషం క్లాస్ చెప్తున్నా. సింపుల్ టు అండర్స్టాండ్ అండ్ యూస్. UML diagrams are not only made for developers but also for business users, common people, and anybody interested to understand the system. The system can be software or non-software system. Thus, it must be clear that UML is not a development method, rather it accompanies with process to make it successful system. In conclusion, the goal of UML can be defined as simple modeling mechanism to model all possible practical systems in today's complex environment. A conceptual model of UML to understand the conceptual model of UML. First, we need to clarify what is a conceptual model and why a conceptual model is required. A conceptual model can be defined as a model which is made of concepts and their relationships. A conceptual model is the first step before drawing a UML diagram. It helps to understand the entities in the real world and how they interact with each other. As UML describes the real-time systems, it is very important to make a conceptual model and then we proceed gradually. The conceptual model of UML can be mastered by learning three major elements: UML building blocks, rules to connect the building blocks, common mechanisms of UML. Any real world system is used by different users. The users can be developers, testers, business people, analysts, and many more. Hence, before designing a system, the architecture is made with different perspectives in mind. The most important part is to visualize the system from perspective of different viewers. The better we understand, the better we can build the system. UML plays important role in defining different perspectives of a system. These perspectives are design, implementation, process, deployment. The center is the use case view, which connects all these four. A use case represents the functionality of the system. Hence, other perspectives are connected with the use case. Design. Design of a system consists of classes, interfaces, and collaborations. UML provides class diagram, object diagram to support this. Implementation defines the components of assembled together to make a complete physical system. UML component diagram is used to support the implementation perspective. Process defines the flow of the system. Hence, the same elements are used in design are also used to support this perspective. Deployment. Deployment represents the physical nodes of the system that forms the hardware. UML deployment diagram is used to support this perspective. So next, use case diagram introduction. Tomorrow we will discuss about use case diagram very clearly with all examples. But today let us understand what is use case diagram. A use case diagram is a dynamic or behavioral diagram in unified modeling language. Use case diagrams model the functionality of a system using actors and use cases. Use cases are set of actions, services, and functions that the system needs to perform. In this context, a system is something being developed or operated, such as website. The actors are people or entities operating under defined roles within the system. Use case diagrams are valuable for visualizing the functional requirements of a system that will translate into design choices and development priorities. They also help identify any internal or external factors that may influence the system and should be taken into considerations. They provide good high level analysis from outside the system. Use case diagrams specify how the system interact with actors without worrying about the details of how that functionality is implemented. There are simple symbols. Tomorrow we will show all those symbols, but today just listen to it. Basic use case diagrams and symbol notations. A rectangle that contains the use cases and place actors outside the system boundaries. Use cases using ovals. Systems are represented by the rectangles. Use cases are represented by the ovals. and we are using verbs to represent the use cases. Actors. Actors are the users of the system. It means who can handle with the use cases. When one system is the actor of another system, label the actor system with the actor stereotype. Actor may be a stereotype. That means an actor can deal with the other system. An actor itself a system, and it can deal with the other systems. Relationships. There are different types of relationships in the use case diagram. A relationship may be a connection between actor and use cases. Yes, there is only one type of relationship, actor and between the use cases. But the way of communication is different. Relationship use cases share different kinds of relationships. A relationship between two use cases is basically dependency between the two use cases. Defining the relationship between two use cases is the decision of the modeler of the use case diagram. This use of an existing use case using different types of relationships reduce the overall effort required in defining use cases in a system. Use case relationships can be one of the following. Communicates. The participation of an actor in a use case shown by connecting the actor symbol to use case by a solid path. The actor is set to communicate with the use case. This is only relationship between actor and use cases. Extends. An extends shows the relationship between use cases. Relationship between use case A and use case B indicates that an instance of use case B may include subjected to specified in extension the behavior specified by A. An extends relationship between use cases is depicted with a directed arrow having a dotted shaft. The tip of arrowhead points to the parent use case and the child use case is connected at the base of the arrow. The stereotype extends identifies as an extend relationship as shown in the bigger as shown in the diagram that I will explain tomorrow clearly, no problem. For example, validating the user for a system, an invalid password is extension of validating password use case as shown in the use case diagram. Include or uses. When a use case is depicted as using functionality of another functionality of another use case, this relationship between the use cases is named as an include or uses relationship. In other words, in an include relationship, a use case includes the functionality described in the use case as part of its business process flow. A uses relationship from use case A to use case B indicates that an instance of the use case will also include the behavior specified by B. An include relationship is depicted with a directed arrow having a dotted shaft. The tip of arrowhead points to the child use case and the parent use case connected at the base of the arrow. The stereotype include identify the relationship as an include relationship. The system boundary is potentially the entire system as defined in the requirements document. For large and complex systems, each module may be the system boundary. For example, for an ERP system for an organization, each of the modules such as personal, payroll, accounting, etc. can form a system boundary for use cases specific to each of these business functions. The entire system can span all of these modules, depicting the overall system boundary. Generalization. A generalization relationship is also a parent child relationship between use cases. The child use case in the organization for the generalization relationship has the underlying business process meaning, but is an enhancement of the parent use case. In a use case diagram, generalization is shown as directed arrow with a triangle overhead. The child use case connected at the base of the arrow. The tip of the arrow is connected to the parent use case. We can take a library management system as use case diagram example. There are two actors in the library management system, a student and a librarian. A member will ask for the book. A librarian will check the availability of book and verify the member details, and after verifying the member details, a librarian will issue the book. If there is any fine for the late submission of the book, librarian will calculate the fine and will impose the fine. A member will return the book to the librarian, and the librarian will keep that book in a particular rack. And the second example we can take as point of sales. In point of sales, a manager, inventory, maintainer, customer, cashier, suppliers are the actors. Supplier, cashier, customer, inventory, system manager, general manager are the actors. And the use cases may be generate sales report, reorder the depleted inventory, updated inventory, check inventory, general checkout, scanning the item, calculating total tax. In the payment, generalization use cases are by check, by debit, by cash card, by cash, by credit card. And next diagram we have to discuss about is sequence diagram. Sequence diagram describes interaction among classes in terms of an exchange of messages over a time. They are also called event diagrams. A sequence diagram is a good way to visualize and validate various runtime scenarios. These can help to predict how a system will behave and to discover responsibilities a class may need to have in the process of modeling a new system. How to use sequence diagrams. Model and document how your system will behave in various scenarios. Validate the logic of complex operations and functions. Basic sequence diagram, symbols and notations. Class roles or participants. Class roles describes the way an object will behave in context. Use the UML object symbol to illustrate class roles but do not list object attributes. Activation or execution occurrence. Activation boxes represents the time an object needs to complete task. When an object is busy executing a process or waiting for reply message, use a thin gray rectangle placed vertically off its lifeline. Messages are arrows that represents communication between objects. Use half arrowed lines to represent asynchronous message. Asynchronous messages are sent from an object that will not wait for a response from the receiver before continuing its tasks. For message types, lifelines. Lifelines are the vertical dashed lines that indicate the object presence over a time. Destroying objects. Objects can be terminated early using an arrow labeled destroy that points to an X. This object is removed from memory. When that object's lifeline ends, you can place an X at the end of its lifeline to denote a destruction concurrence. Loops. A repetition or loop within the sequence diagram is depicted as a rectangle. Place the condition for exciting the loop at the bottom of left corner in square brackets. Types of messages in sequence diagram. Synchronous message. Excuse me. A synchronous message requires a response before the interaction can continue. It's usually drawn using a line with a solid arrowhead pointing from one object to the another object. Asynchronous message. Asynchronous message do not need a reply for interaction to continue. Like asynchronous messages, they are drawn with an arrow connecting to two lifelines. However, the arrowhead is usually open and there are no written messages depicted. Reply to written message. A reply message is drawn with a dotted line and an open arrowhead pointing back to the original lifeline. Self message. A message an object sends to itself, usually shown as U shaped arrow pointing back to itself. Create message. This is a message that creates a new object similar to a written message. It's depicted with a dashed line and an open arrowhead that points to the rectangle representing the object created. A delete message. This is a message that destroys an object. It can be shown by arrow with an X at the end. Found message. A message sent from an unknown recipient shown by an arrow from an endpoint to a lifetime. Lost message. A message sent to an unknown recipient. It's shown by arrow going from lifetime to an endpoint. A filled circle or an X. We can take the same sequence library